first, then 10th, like that. Randomly, I'm picking the 50 vectors for training and remaining vectors for the testing. Got it? Fine. Very good. Then what is the next? Right? So you are collected and you are arranging train data 1, test data, and this is just a plot of the individuals. And this one I already explained, right? KLDA, you are computing that and you are finding out these eigen vectors, and here this projection is happening. Huh? Yes. Good question. What is EIGS? Anybody? What is the difference between EIG and EIGS? There are two commands. I don't know whether I use EIG at the top or not. I use EIG at the top. Okay. You can actually use both EIG as well as EIGS. Both will end up with this eigenvector and eigenvalue. The only difference is in case of EIGS, I can put how many you want, how many eigenvectors you want. This is just 2D, so this you will not appreciate this. I mean, much actually. But when you are working with very huge, see, the same code can be used for very high dimensionals. Ditto, no change, same thing we can use. But in that case, 2500 eigenvalues or even more, right? It takes time. It takes computational time actually for computing those many number of eigenvectors, eigenvalues, right? So what we do is we use this EIGS of that covariance matrix, comma, the number of eigenvectors you want. Significant. It is going to select only significant eigen values and then corresponding eigenvectors, but how many you want, right? So that is given as a second variable. EIGS of, what is it? Yeah, EIGS of comma 1 I have given. Comma 1 means I want only 1 in this case. But in other applications, suppose if I want to have 10, I can simply put comma 10. But in case of EIG, the command EIG, I will not give how many I want, right? So it will calculate actually fully. Suppose that if I have 2500 is the dimension of the vector, your covariance matrix is going to have the size of what? 2500 cross 2500. So it is going to compute 2500 eigenvalues and then corresponding eigenvectors. It takes time. At least 2500 is fine, but still, if you have still bigger thing, it will take time. So you whatever you want, right? So that I can do. And EIGS will collect the eigenvectors corresponding to the significant eigenvalues. Meaning you are going to arrange the eigenvalues in descending order, and then you are going to select the best, the topmost, right? So I'm saying 1 doesn't mean that arbitrarily it will choose the eigenvector, right? It will choose the eigenvector corresponding to the largest eigenvalue, right? So that's the meaning. Got it? Good question. You ask, then only I can tell. I can dictate, that is a different story, but you are familiar with MATLAB code there. So any other doubt you are having? The last one, what I have done, you may wonder, right? You are getting some yellow color, blue color, what is that, right? So basically, right, what I have done is the distance matrix, nothing else. I told after projection, if I want to know how the vectors are arranged, right? So you can actually make use of what? The distance matrix to do it. Got it? So here, see here what is then done here, you see that. So the distance between the vectors x1 and x1 is a matrix, right? So the I and j will give you the corresponding vectors. Got it? Right? The first vector of the matrix x1, column vector, and then first column vector of the matrix x1, we are finding out just the equidistant distance, right? You are squaring them, and then we are doing what? Simply sum. It means that it will find out the distance, right? And keep on adding all those things. It means that the vectors belonging to one particular class, all the distances, 1 with 1, 1 with 2, 1 with 3, everything, right? So that is being calculated, summed together. That is stored in what? Temp1. And similarly what? You are having this temp2, it is between again x2 and x2, right? Got it? And then y1 is after projection. After projection, how the vectors are closer to each other. This is basically giving you the information about after projection, how the vectors are coming close to each other, right? So they are arranged in what? Temp1, temp2, temp3, temp4. What do you say? Can you see the values of that map? Just type NAT in the command window. See what is the value you are getting. MAT, the command window. What are the values you are getting? What do you observe? What do you observe? Hmm? No, that's fine. Okay. What is that bottom two? Huh? Right. So what does it mean? After projection, the vectors are closer to each other. Right. So what you expect is that bottom two should be much lesser than the top two. This is about the between class, right? I mean, sorry, within class, how far the vectors within the class are close to each other. The top two are the distances between the vectors within the class, right? So that is having some value, right? So yellow color and orange color, we have some distance is there. But after projection, the distance is almost zero. At least it is lesser. I cannot say it is zero because we have into 10 to the power of 3 exact number. If you want, I have to see to this, 2 comma 1, right? Yeah, 0 only, 10 power minus 11. Okay, 10 power minus 11, right? So you can see that 1 comma 1, it is 10 power 3. Raw data, you have that much big distance actually available between the vectors. But after projection, the distance is almost 0. 10 power of minus something, right? So that's what this figure is indicating. This figure is showing that only, right? So I want you to change the sigma, and I want you to show, this is now the skill test, right? For only 5 minutes. If you are finishing that, you can leave. That's what the idea behind it, right? So the testing data projection is there, no? Testing data projection, not training data projection. Testing data projection, how it is looking? 1D projection. Yeah, that is training data projection, right? Training only, no? Left side, bottom, left, training. Right is, I want the testing data projection to look like to that level of what? The training data projection. What is in your hand is sigma. Change it and tell me who is getting, we'll see. Sigma is the default value and you're choosing is 0.1, right? You can change 1, you can just set it, and accordingly you can reduce it or increase it so that you want a good separation. Any question? In that, you open the transaction for the final. So if someone is able to get apprehension for the testing data by putting different value of sigma, from the from the I mean data machine learning, right? See, we have to stop training, or you have to be happy in the sense that the model is ready only by checking with testing data. Training data, mostly it will work, but for the testing data also, if it is working, then only you can go for the launch. Understand? So testing data, you cannot, it is a essential part of the machine learning algorithm, that for the completion of this algorithm, right? So training data, it is working, so we can launch. No, training data, it will work, because that's what mathematically we tried. So it will work automatically. It will bring this, that, how it will do. But testing data, if it is working for testing data, then only it is ready for launching. That sigma you have to freeze. You have to freeze it and we can launch. Until then, see, they are tuning this hyperparameters, still it is an open problem. That sigma getting automatically the sigma no. No, as of now, right? But of course, even myself, I propose one way to choose the sigma. Again, it's more cumbersome, I mean, difficult only, but go for only trial and error. That comes under this hyperparameter. Those tuning parameters we have to play, we have to sense. In fact, what we do is we put a very big loop, change the sigma value for the long range, and check this performance, right? For the testing, not for the training. Training we don't check normal, right? Testing data we check until we get a good separation. That can be done using metric. How far these are closer to each other? That metric, what we have computed, no? The computation we do it for the testing, not for the training until we get a good value, almost zero. We'll stop there, and then we freeze that sigma and we launch it. That is the way how we have to do, right? So no, wait, we have this is someone that starts moving. Yeah, we can put one more. Not a number is excellent, excellent. Very good, very good. See, I'm happy that two, that is what we are sigma equal to 0.00. So you choose the sigma value 0.00001, right? Or 3 zeros. 4 zeros. Use this and check 0.00001. Sigma. Covalence matrix of the matrix. So, see, I want you to check this. First covalence matrix. Then, what? That's what I'm writing here. That's what I'm doing. What for the second one is 0.7, 0.1. Use this covariance matrix. See, I tell you that by using a different covariance matrix, the data whatever you are generating is going to be different only, no doubt in it. But still, for the same covariance matrix, you please use this and show me. You got it? Are you able to separate? No, that's not true. Use this. Px equal. And make sure use that one. Your use this 0.00. I got 0.001. Okay. Oh, 0001 it is okay. Yeah. And separating. Yeah. So what I want you to yeah, you separate. What I can. They are knowing what to be done, like what the training and what is main training. So I told that works very well for the people. We have to work, keep on changing the technology. But reality also, for real, this is what exactly the job. We have to do this tuning until it works out for proper metric instead of visualizing the same thing what you are doing. And you have to stop until you satisfy that testing. If it is satisfied, testing. I think the basics you understood about the dimension reduction, right? So you can go through the corresponding topics again to get it more, right? Details. We'll stop here. Yes. Cross and circular. Okay. Yep. Okay, let us go. I click the photo. So tomorrow at 10 we'll start. Please be there by 9:45, 9:50.